I think you have understood these types, these variation, the variants of hybrid electric vehicles, namely series. The ICE engine is there, but not taking the road loads. So it is just used to generator, used to run the generator. Parallel, ICE engine is there and it will take road loads as well. When we combine both of them, combination of both of them, so as to extract benefits from series as well as parallel, we get series parallel. And then another one is complex, wherein instead of two power propulsion units, we use three in the form of motor generator as well. So we have got one ICE engine and two motors, right? Of course, this motor will work as a generator as well. And that's why the flexibility is a lot more here in case of complex. And complex compounds are used when we talk of hybrids, that is 4x4 arrangements. Okay, I think we have gone through this. Now this is typical configuration of series electric hybrid drivetrain. So earlier one was kind of schematic, but this would be a more detailed schematic, I would say, wherein you will get to see all the important elements which comprise of a series hybrid. So here we see we have got an engine on one extreme, we have got the wheel, and then here we see motor, but then the engine is coupled to generator. So engine, the job of engine basically is to run the generator. We have got electric coupling device here. This is peaking power source, so PPS, which is nothing but the battery. So the general word that has been used here is peaking power source. Why? Because power source may not necessarily be battery. It could be anything else as well, apart from battery. So that's why the generic word has been used here, peaking power source. But for sake of simplicity, for sake of understanding, we may take it as battery. So we have got battery, we have got electric power coming from battery, we have got electric power coming from generator, which could be DC or AC, and that's why we need a power converter, electric coupling device in the form of a power converter. And then we have got motor with its controller, so motor and motor controller, and then it would go into the transmission, right? And from transmission, the drive would be transmitted to the wheels through the rear axle. So point here is engine is there, but engine is not taking road loads, and that is the beauty of this series hybrid, right? Which means I am free to run my engine at the speed where I can derive optimal operation from my engine. Hello, are you there with me? Can someone of you just confirm? Am I properly audible?
Yes, yes.
Okay, fine. Okay, so I will go ahead. So point is, engine has been deployed, but then it is not taking road loads. And what I was talking about is engine, we are free to run the engine within the speed band where we can derive the maximum or optimal performance from the engine in terms of power, torque, right? And the least fuel economy and lower emissions. That is possible in case of series hybrid. Apart from this, of course, apart from this drive line, the another important part that has been shown in this figure is there are a lot of controllers as well. For example, here along with motor, the motor controller has been shown. Engine will come up with its own controller, so engine controller, and then at the supervisory level there is this vehicle controller, right? And then there is this mechanical brake controller, and of course here it has not been shown, but then this battery will come up with its battery management system or controller. So the controllers are again going to play a huge role in the operation of hybrids, and that is why we would explore the control aspect of hybrid electric vehicles as well, right? So I think this topology is now well understood as far as series hybrid is concerned. The power flows have been shown with the help of this variety of lines. The arrow is talking about signals, electric power, and then mechanical connection. So we can see mechanical connection is present over here. And then the communication has to be established, communication between the controllers. So vehicle controller, engine controller, mechanical brake controller, and motor controller. So these controllers should be talking with each other, right? And how would one would make them talk with each other? Of course, with the help of electronics. And then when we talk of electronics, there are a lot of sensors and actuators that come in the picture. So literally these days, hundreds of sensors are available on the on board of vehicle, right? And with the help of these sensors, these signals are captured and these are delivered to the actuators. So actuators are nothing but here motor is one actuator, engine is and generator is another actuator, brake is another actuator, right? So with the help of these electronics, and lot of electronics plays a very important role, the operation is streamlined as far as series hybrid is concerned. So what are the advantages of series hybrid? Why it is preferred in some cases? As I said, engine can potentially be operated at any point on its speed torque map. So we can expect the optimal performance from the engine in this case. We can use high speed engines as well because the high speed engines are more economical. So high speed engines use of high speed engines is possible. The drivetrain may not need multi-gear transmission. Why? Because the whole road load is being taken up by electric motor. And as we have seen yesterday, in case of electric vehicles, when the power propulsion unit is motor, right? And I think we compared the characteristics of ICE engine and motor, right? And the characteristics, power and torque characteristics are motor are such that we don't require the transmission, or even if we use transmission, mostly it would be single speed or two speed. So definitely with electric vehicles or with series hybrid electric vehicles, one is not required to use multi-speed transmissions like four speed, five speed, six speed transmissions that we come across in case of conventional vehicles, ICE engine powered vehicles. So that is not the case for sure, right? So that's why here it has been said the drivetrain may not need multi-gear transmission. Mechanical differential can be removed by using two motors. So as yesterday also we talked about, we have seen in case of electric vehicles, instead of one motor, if we come up with two different motors, one can dispense with differential, and that brings a lot of mechanical simplicity. It removes the complexity. And then if we use four motors, then of course all-wheel drive or four-wheel drive is possible. But the most important advantage is the control strategy of the drivetrain is simple. Why? Because what we need to do is, because it's only motor who is going to take up the road load. Though engine is present, engine is not taking road loads, and that's why comparatively the control aspect is very easy or simple in case of series hybrid, series HEV, right? Okay, fine. But then, of course, it comes with the limitations as well. And the major limitation of series hybrid is what? The overall efficiency is less. Now, why? Why the overall efficiency is less? Because the energy gets transformed twice, right? So what happens is the engine, you burn the fuel, so chemical energy is being transformed into mechanical energy, and this mechanical energy is getting converted into electrical energy in the generator. So this is where the transformation is occurring. And then since you are using motor, so which means the motor will be supplied electric energy, and this electric energy is being consumed and it would be transformed into mechanical energy. So point is, so more the transformations, more the number of stages, the transformations from one form to the other, right? The losses would be more, and as the losses are more, the efficiency would be less. So that is a problem with series hybrid. And then we are going to use generator, so it comes with its own weight and cost, right? And then the major limitation is the traction motor must be sized to produce enough power. So what it means is, since as we have said, this electric motor is going to be responsible for taking the road loads, which means I will have to size the electric motor taking into consideration the road loads. Or in other words, what it means is the electric motor that I would be using here, right, the traction motor, it is required to be of big size. Big size means high power rating, right? So low power rating motors will not be possible here. I will have to use high power rating motors, right? The kilowatt capacity of these motors required to be on higher side. Why? Because though I'm using ice engine is not taking up any road load, right? So this is a major limitation of series hybrid. Okay, I think we have covered this series hybrid. So of course we will take up questions if you have any at this stage, right? But then at this stage we will move forward, and towards end, maybe if you have any questions, we will take up those questions. Okay, now moving to this parallel electric hybrid drivetrain. So here we have this parallel electric hybrid drivetrain. So here we see both units are there, engine as well as electric motor. The engine comes with its own shaft, and since we are using engine here, we have its own transmission. So engine transmission. Of course, there is a clutch in between. So engine, clutch, and transmission. So this is our regular powertrain, the ICE engine powertrain. And in here we have got a motor which comes along with its motor controller. There is the battery as well, because we will need power supply to be fed into the motor. So battery, motor controller, and motor, right? And then we see here two different shafts. So motor has got its own motor output shaft, the transmission shaft, and we are going to use a torque coupler here. As we have said earlier, the torque coupler is nothing but a mechanical element, which could be a chain and sprocket, it could be a belt and pulley, or simply it could be gear pairs, right? And then the drive is being transmitted to the rear axle, and through rear axle to the wheels. So point here is engine has been deployed, and the engine is responsible to take up the road loads. Of course, there are other controllers have also been shown, similar to earlier case. So engine comes with its engine controller. There would be communication between engine and engine controller. There is a vehicle controller at the topmost level. Again, there would be communication between the vehicle controller and engine controller. Similarly, there is this mechanical brake controller as well, right? So the braking signals could be captured, and these are going to be fed back into the brain of vehicle, that is vehicle controller, right? So point is, a lot of communication. The control aspect plays a very vital role, important role in the overall functioning of parallel hybrid as well. But the major point here is that we are using engine, and the engine will now take up the road loads, and that's why the earlier advantage what we were getting in case of series hybrid, that is the high speed engines could be used, or it was possible for us to run the engine within its the most optimal band. Now that has not been possible here. So I hope that you have got this parallel hybrid electric configuration in more detail, right? But now then there are two different types. In case of parallel hybrid drivetrain, we have got two variants. One is torque coupling, and second is speed coupling. So what is torque coupling, speed coupling? Of course, we'll go through. We'll quickly cover that as well. So torque coupled. So well, I think there is some noise that is coming up. Can you please switch off the? I think there is some noise that is coming up.
All are muted, sir. No problem.
Okay, okay, thank you. Okay, so torque coupling we see here. This is mechanical torque coupler. So basically, torque coupler is nothing but the element that we are talking about, right? Basically, the gear pair what we talked about, or the chain sprocket, or the belt pulley with power transmitting element that we talked about. These are nothing but basically mechanical torque couplers. So there are two input ports, port 1 and port 2. We are going to have the torque and angular velocity T1 omega 1 coming through port 1, T2 omega 2 coming through port 2. Say for example, in this case, of course, the one port will take the torque from ICE engine, another would take from motor, right? And this is the output port 3, where we are getting T3 and omega 3, right? So T3 and omega 3 is nothing but the power output, right? P is equal to T into omega, that That is the basic expression that we know, right? So basically, torque multiplied by angular velocity, that is nothing but power. So what we are trying to say here through this mathematical equation is that the power output at port 3 is equal to power output at port 1 and port 2. So T1 omega 1 plus T2 omega 2. And then as far as torque is concerned, only torque is concerned, that is T3 output torque. So it is equal to K1 T1, K1 times T1 plus K2 times T2. And this K1 K2, these are referred to as structural parameters, or those of you, I think most of you would have mechanical background. So K1 and K2, these are nothing but the ratios that we talk about, the power transmission ratios. For example, in case of gear pairs, it could be Z, isn't it? The gear reduction ratio. So depending upon this, in case of say belt and pulley arrangement, basically it will deal with the ratio of diameters of pulleys. Or in case of chain and sprocket rise, basically two sprockets, so the ratio of number of teeth on individual sprockets, right? So basically it is power reduction ratio, right? So K1 and K2, depending upon this relationship K1 and K2 values, the output torque would be estimated here. And the other one is speed coupling. So speed coupling, basically now we are using some other speed coupling devices. For example, it could be either planetary gear unit, or it could be a case of electric motor with floating stator. So this is called as transmotor, right? So see, try to understand the difference. We have said that torque coupling, we are coupling the torque. How? Either we are using gear pairs, or we are using belt pulley arrangement or chain sprocket arrangement, right? So then it becomes a case of torque coupling. Torque is being coupled, while in speed coupling, and the speed coupling is also important because the important advantage that we get out of speed coupling is that we can decouple the individual speeds of electric motor and IC engine from the vehicle speed. That is the advantage to go for this speed coupling, right? So when we use planetary gear unit or this transmotor, we basically are talking about speed coupling. So here the speed has been coupled. Omega 3, that is output port, port 3 is the output port, omega 3, that is angular velocity at port 3, that is equal to K1 omega 1. So here it is port 1, which could be, say, for example, belonging to engine. So we are talking about engine speed, K1 omega 1, plus K2 omega 2. So omega 2 is, say, for example, motor speed. Omega 2 is the motor speed, and K1 and K2, these are structural parameters that we have talked about. So depending upon this relationship, the speed would be governed, right? And that's why this is called as speed coupling. So we can have two variants. One is torque coupling, and second is speed coupling. So see, we have seen that the hybrids by and large could be categorized as micro, mild, and strong. Then based on the architecture, the topology, we have seen that these could be categorized as series or parallel, or series and parallel and complex. And now again, going into the further details, if we talk of only parallel, which is the popular architecture used for cars and SUVs, passenger cars and SUVs, we are now talking about these two variants. One is the torque coupling, and the second is speed coupling, right? So torque coupling and speed coupling. No, this is what we mean by the torque coupling, right? So here what has been shown is a two shaft configuration. So typically we have got engine, we have got motor. Now engine would come up with its own transmission, motor will come up with its own transmission, and here we have got the torque coupling. So two shaft configuration because two separate shafts have been used here. So that's why it is called as two shaft configuration. But again, now see how much flexibility it offers, right? For example, there are four possibilities. One possibility is that transmission 1, which is connected to engine, could be multi-speed, and transmission 2, which is connected to motor, could be single speed. right? So this is multi-speed, this is single speed, right? And that is the most practical combination that we can have. But then other three possibilities also exist. So other possibility is transmission one is single speed, while transmission two is multi-speed. The possibility is very low this to happen. Third possibility is transmission one could be single speed, transmission two also is single speed. So both transmissions are single speed. And possibilities four is transmission one is multi-speed, transmission two is also multi-speed. Right? So when we think of these possibilities, four possibilities, then we get, variety of options that are possible. Right? So here, quickly, I will just kind of present this slide in front of you. What I want to show is that all these combinations are possible. For example, figure A is talking about two multi-gear transmissions. So when we have got two multi-gear transmissions, and if we consider that there are three gears, three forward gears in transmission one, and three forward gears in transmission two, look at the options that are available, right? Which means you are in the best position to utilize the power delivery from motor and IC engine. But of course, it will be complex as well. And at the other extreme, we have got this configuration D, wherein both transmissions are single speed transmissions, only one gear. They are comprised of only one gear. So it looks very simple, not complex at all. But then from the flexibility point of view, from optimization point of view, of course, we will have some limitations. And in between, we can have these two possibilities, B and C, right? So B is multi-gear engine transmission, which means engine comes with multi-gear transmission and motor comes with single gear transmission. Or here, in case of C, single gear engine transmission, but multi-gear motor transmission. So point here is when I develop a hybrid electric vehicle, I will have to make this decision. So what kind of decision, whether I want to go for strong hybrid, mild hybrid, right? Or micro hybrid. Second thing is whether I would go ahead with say series architecture or parallel, or series parallel or complex. And then if it is parallel, then whether it is to be torque coupled or speed coupled. If it is torque coupled, again whether it is going to be two shaft configuration or single shaft configuration. I will come to that as well. Single shaft configuration is also possible, wherein we use a common shaft for engine and motor. So that is referred to as single shaft configuration. And then if it is two shaft configuration, then another design decision that has to be taken is whether the engine will have a single shaft, a single speed or multi-speed transmission, and the motor will have whether the motor will have single speed or multi-speed transmission. Right? So a lot of flexibility is available. Now this is what is called as single shaft parallel hybrid electric drivetrain pre-transmission train. Right? So single shaft, why it is called as single shaft? Because as you can see in the image, we have got a common shaft for engine and the electric motor. So this unit is electric motor, and there is a common shaft which is joining engine, connecting engine and electric motor, and then comes transmission. Right. So here the electric motor is arranged before transmission. Pre means before. The electric motor appears before transmission, and that's why it is called as pre-transmission type. Right. That is single shaft parallel hybrid with pre-transmission. Right. So if there is a pre, of course there is post as well. So in another configuration, what we can have, this kind of arrangement wherein we have got transmission first and then electric motor. So which means whatever the torque that is coming from engine, that would be amplified here, multiplied here, and then it would go into the electric motor. Right. When in earlier case, collective torque of engine and electric motor, that was being amplified or leveraged here in the transmission. So this pre-transmission, isn't it? This is commonly used for mild hybrid drivetrains. So wherein the electric motor functions as engine starter on electric generator and engine power assistant and for regeneration. right? So here the multiple uses are possible. With electric motor is playing a role of engine starter, so it is used to start the engine just like conventional vehicles. It works as an electric generator, it works as a power assistant, it is supplementing the engine power, and then it is being used as a regenerative unit as well, right? While the post transmission also could be used, but then the problem here in this case is the batteries will not be possible. It will not be possible for us to charge the batteries, right, by using the engine. So this is a limitation of post transmission kind. But then we need to bear in our mind that two shaft configuration as well as single shaft configuration is possible in case of parallel hybrid electric drivetrain. Well, depending upon the configuration, we can have another option available for us, and that is called as dual axle or separated axle kind of parallel hybrid drivetrain. So say for example, I have conventional vehicle, IC engine powered vehicle, and I want to convert it into a hybrid vehicle, which means already I have this conventional powertrain, engine powertrain, and I want to add another powertrain, that is electric powertrain, on the existing vehicle. So this is something called as retrofitting, right? And in this case, the separate axle parallel hybrid drivetrain could be possible, or it would be more handy or more practical. So what I would do is I am not going to disturb the rear axle driven arrangement. So here what has been shown is the engine and transmission, they are responsible to make this axle as live axle, rear axle. So this is a rear wheel driven vehicle earlier, but now what I do is I come up with this electric motor, electric powertrain, that is motor with its controller and batteries, and then transmission. And then with the help of this motor, I am trying to make this axle as live axle, front axle. So now my front axle is also live, rear axle is also live, which means four wheel drive arrangement is possible. But then I have not disturbed the existing layout, right? And this is, so that's why it is called as separated axle. So separately, the engine separately provides drive to the rear axle. The electric motor separately provides drive to the front axle, and that's why it is called as separate axle parallel hybrid electric drivetrain, which is most commonly used for retrofitting kind of purpose, which means the existing vehicle, conventional powered vehicle, and I want to convert it into a hybrid vehicle. So that is where it is this option is popular, right? So I was saying, so why to go for speed coupling? The reason to go for speed coupling is because I can detach the speeds of two power plants. Which are the two power plants? One is engine, another one is electric motor, right? So speeds of these two power plants, one can decouple, detach from the vehicle speed. So what is the advantage that I get out of it? I can run the engine at its most favorable speed. Similarly, I can run the motor also at its most favorable speed. So the speed of both power plants can be chosen freely. And especially this matters if I intend to use, say for example, Stirling engine or gas turbine engine, right? Why? Because the efficiencies of Stirling engine and gas turbine engine, these are very much sensitive to speed. They are very much dependent on speed. So speed is the governing or influencing parameter in this case, gas turbine or Stirling engine. And that's why in those cases, typically one would think of using speed coupled parallel hybrid drivetrain. So both these examples have been shown here. So this is speed coupling wherein a planetary gear train has been used. So we see here engine, transmission, right? And then here we have got this motor along with motor controller and batteries. So conventional powertrain, this is our electric powertrain, and then both of these have been clubbed together with the help of this planetary gear unit. So this is one option. This could be one case, right? Or the other case could be we use transmotor instead of planetary gear train, planetary gear unit. We use transmotor, electric transmotor. So we have got engine, transmission, we have got electric motor and batteries along with its controller, and then This is basically the transmotor, which means electric motor with floating stator. Right? So this is how we can implement the parallel hybrid drivetrain with speed coupling. Now, this was the first part, I would say, first part of hybrid powertrain. Now, let's come to the second aspect, second part of this hybrid electric vehicle technology, and that deals with the important issue of control, right? So, because we earlier in earlier case, for example, conventional powered vehicle or electric vehicles, we are talking of only single powertrain, one powertrain. So, the control wasn't really a big issue. But here in this case, since we are dealing with two separate powertrains, right, then the issue of control becomes of prominent importance, right? So let's get through some details, some